agree that null hypothesis is true. That is the basic statistics. Okay, and we looked at a chart which said that there is a center point. There are 3 standard deviations on the right and 3 standard deviations on the left. Anything that falls outside this is basically an outlier, which may not be very helpful for statistics. It's like having a BPF. We look for values that are within the distribution, and we either agree or disagree based on where that point lies, how many standard deviations away from the center. So far so good? Good? Yes. This is a brief 2-minute video, right? Because this is after lunch, I wanted to kind of, we recap the statistics. We go back a little bit of life, the real life, catch up and then come back to statistics. Okay? 6 of us trekking on that second most medianist road in the world. That is cliffhanger. Landslides along the way. You don't see any humans all day. Okay? It's snow and you are trekking in the snow. That's the terrain, higher Himalayas. That's the festival, that's the temple in India. These are some rituals at the temple. We stayed in a village, a local village. That's me all geared up with the monkey cap and the jacket and the This is the local drink they would give you to deal with the cold. Yeah. This is our group leader. The kids rarely see somebody other than their village people, so we happen to be some of them. A lot of wilderness. So if you go put a word in Google, just spend 5 minutes, put data science. There will be hundreds of articles coming up. Okay? You will be lost on what to read only. That is the volume of information available on the internet. Both good and not so good. Not so good in the sense it is a maze. If I throw a needle on that carpet and say go find it, you can take whole day. You never know whether you will find it or not. So it's like that. And the idea of these sessions is make some of that known to you so you don't get lost. Okay. When we went up there, we had Sherpas. Sherpas are people who are in the mountains. They exactly know the terrain. They hear a sound, they know what animal it is. They see something on the floor, they know there may be a wild bear that just walked by. They hear a yawn of some animal, they know that animal could be hungry or it is stomach full. So we are safe to go. If it is hungry, not safe to go. We could be that food of that animal. So basically, that is how you take some of these ingredients that we are talking today. And this is not all data science. Let me clarify. We only touch upon 2 or 3 key pillars. One, hypothesis and regression and multilinear regression. Then we move on to automation, robotics, and then digital workforce, and hybrid cloud, etc. Those are more on the application side. But the foundation, we are touching only the 3 pieces. Okay? So like we had Sherpas to guide you, what your institute and your curriculum and sessions like these and people like me are trying to give you are like a torchlight on what to look for. Okay. Now you know hypothesis in the morning. You will know linear and multilinear regression in this session. So you have the torch. So if you want to learn more, you can still go deeper into those topics. Because there are a lot of Harvard published business case studies on these topics only. They have taken very interesting case studies and they have solved them. Right? So you could also, you know how to form the equation now. You know how to deal with the data. You know the statistical value, or the critical value. Very simple. Take the data and apply the equations to the same. Okay. That was the intent. Now constant error term E. In the morning we talked about outcome and dependent variable. E is what completes this equation. And we'll talk about why we talk about error. Error is also a critical part of completing the problem, right? So, what is y here? Outcome here. Y is what you are trying to find out more about. What is x? Dependent variable. In our hospital case, y is your package cost. X is a weight or somebody's age or something else that could influence the cost. Now, in single linear regression, we only look at one parameter that is influencing the cost. Okay? We only look at one parameter. In multilinear regression, there will be multiple x's. Okay? Here we only take one and try to solve the problem. Okay? It is like you, let's say you have a website. Anybody uses Meesho?
Yes.
Shopify? Cool. So if I take the data of Meesho or Shopify, it will tell so many customers, maybe some of you who are already buying or looking at the websites are the customers. So many times they logged in the day. How many times you would have logged in the day? 3, 5, 15? Maybe more. Okay. So how much time you spend on that website? 5 minutes, 10 minutes, 15. Time is available, right? And what device you get on to that website? Mobile, tablet, desktop, laptop, etc. And what time of the day you get on? When do you think most of the shopping happens? Huh? 5:30. Credit card, one scratch on the credit card, gone. Or weekends, when you are sitting and hopefully you don't have much to do and you are like, okay, let me browse this. Let me just see what happened. How does this M1 chip map Pro looks like? That's it. Slippery slope. Boom. Right? So now we talked about a business case where there are users going onto a website and the type of device they use on the website, the time of the day they get on the website, how long they spend on the website. Okay? Now let's say these are 4 variables. The single linear regression will only focus on one most critical part of it. It doesn't get into the 4. Okay? It inspects several and it takes one and says this is it. Let's say that is the time of the day as an argument. So it only looks at x, then will become your, what will be the x? Dependent variable. And what is that? We just said time of the day. That is the dependent variable. Several x's dependent variables. There is one outcome. If we inspect only one variable, it is single linear regression. If we inspect multiple, what is the effect of time of the day? What is the effect of which device they use? Which time of the day? Then it becomes a multilinear regression, right? So we'll start with the very basic part of it, that is single linear regression, inspecting one variable. And then this is called constant or error, right? We'll get into it when we actually do the example. Okay? So the goal of predictive modeling, what are we doing here? We are trying to predict y based on x. So the goal of predictive modeling is uncover the true function that relates a series of variables which are x with some outcome that is y. Use that model to predict the outcome for some additional observations. What it means is, once you nail the equation, let's say the package is dependent on age of the patient, can you predict only for that patient or any patient? Any patient, because once that equation is fitted, you know age multiplied by, let's say, 1.3. If we go back to the equation, your age is your x, right? And the variable, the constant, that multiplier, let us assume, is 1.3 or 1.4, which means for every year of age increase, there is a 30% increase in the package cost, right? So once you know, it doesn't matter then, whoever is the patient, wherever is in the world, if that person is coming for this hospital, this is how the financial model will look like, right? That is the expectation with the second bullet here. Use the model to predict outcome for any additional observations also, right? You infer from 50, let's say you have 50 patient data. Once you form the equation, now you can figure out for another 10, another 20, you can figure out, right? That's what it is. The challenge, this is the key part. We don't know what the true relationship is, and every sample has noise. Now, what is noise in the system? Noise could be something that could influence this variable. Okay. Normal variable is anybody at that age, at that height, in that average, maybe a BP range or a sugar range, or in that average ECG, right? But 1 in million could have a heart problem, okay? That it doesn't cover. This equation is not going to cover, because this equation is only taking the age, right? It's a single linear equation, right? So those kinds of parameters that may become noise will influence your outcome. Is that a good thing or a bad thing? It is a bad thing, because you cannot account what is the cost for such complex case. So you need to be aware about that noise that may influence your data, right? We use various modeling techniques to strike the right balance between fitting the signal and not fitting the noise in the sample. So we will use some techniques that we will figure out along the way. So we know what could be the noise. And one easy way to figure out noise is outlier. ECG of a heart patient, will it be similar to a regular patient? No. So if you put the ECG, and the ECG indicates with its graph that something is wrong with this person, then you say that, wait a second, I have made a model for normal people. For this person who is a noise in the system, I cannot apply. This is a special case. So outlier is a very good way to figure out that there is noise in the system. Okay? Let's say somebody collects your data. They are making a statement that average age of this, let's say 50 people sitting in the class is 23. Is that a fair statement? No. Upfront you can know it is not a fair statement. Somebody says average age of this class could be anywhere between 17 to 19. Is that a fair statement? It's a fair statement. So outliers you can figure out and eliminate the outliers from your model. The moment you include the outliers, it will influence your overall outcome, which could lead to wrong outcome prediction. We talked about in the morning. How many standard deviations are there? What kind of bias is, the more you add more variables in multilinear regression without addressing outliers, it will induce a bias into your outcome. Example, it may say that, let's say all of you watch IPL. Yes, sir. Yes. Good. So let me make a statement. Every time match happens in Mumbai, they are making 50 crores. Stadium is making 50 crores. Okay. Now, let's say Rohit Sharma comes and claims that 50 crores, you have to give me 25 crores. Why? Because I am playing for Mumbai Indians, they are coming. Mumbai Indians is nothing without me. Now what happened? It is a bias. Okay? He is saying that your outcome is biased because of me playing in the level, not because you are Mumbai Indians. So bias also influences your outcome. So there are certain modeling techniques to eliminate the bias. Either validate, agree, or validate, disagree. Right? So we need to be aware about the bias in the equation. Okay, we talked about this. Briefly. These are the subtypes. Because there could be errors. Like let's say somebody says, somebody in this class is 42. Do you need to keep the data or remove? Remove the data, that's incorrect, right? Divide the data into training and validation. This is a key piece. Okay, what it means is, let's say I want to do some testing with this class. Okay, that could be like the same health drink I want to give to this side of the people and not give to that side of the people. Okay. Now, when I am building my equation, if I use everybody, that is a full data set, which is both the entire population. Now what happens is, I give you the drink already. Now I arrived at a conclusion. How do I test? Because the drink is consumed by somebody in the age of 17 to 19. Now all the 17 to 19 in this room are consumed. Let's say I, Mohan and sir, a photographer and the cameraman, both are, they are not in the 17 to 19. How do we test? If we test on us, what will happen? Can you test that equation on us? No, because that is not formed for that type of data, right? So what happens is, once you have the data, you retain some data for validation. Don't use all the data for equation forming, never. Typically 70 to 80% you use, 20 to 30% of the data you keep for validation. That is a key part of data science. Leave the data for training and validation. Estimate the regression parameters. We talked about multipliers, that constant that come into the equation. Then perform regression model, the equation through Python. We'll get into that. Validate the model and decide the model deployment. Now validating the model. What is validating the model? Whether this model is belong to this population, or can I deploy it in the field? Okay. So you need to ensure that whether this model is deployable. There are some diagnostics for that. One of them, critical diagnostic, is called R-square. That R-square will come into it in the slides. What it says is, what is the probability that this model is applicable? If that probability should be higher or lower, what do you think? Lower? Okay. I'm saying I have an equation. I am going to apply to this model. And the probability of that equation coming true is 10%. Is that good, or probability of that equation coming true is 70%? Which one is 70%? So you need a higher probability. So with the same equation, once you get the model, you have a way to validate the model with the R-square. The higher the value of R-square, the better it is from a modeling perspective. Right? So you do that, validate the model and decide on the model deployment. These are the basic framework for any model. Not only regression, any type of model, your data for argument. Now I have a name, I have age, I have a male female indicator, I have your body weight, and maybe several other parameters. Okay? Now, how do I collect your weight? There is a number. Your age, there is a number. With the sex, male, female, how do I collect? Louder. Gender. I'll put a male and a female. Now, in that equation, which I collected the data, what is your age? Number. What is your weight? Number. But what is your sex? Is it a number? It's a variable. It's a character, right? Now, do you think any equation that I apply will treat them the same? No. So, for modeling, what those are called are categorical variables. Okay? A car is a normal variable. How many cars you have? 3 cars. What model of car? Categorical. I have a Verna. I have a Hyundai Santa Fe. Verna is a different pricing. Santa Fe is a different pricing. So you cannot compare. But I have a car, you can use that. Likewise, for categorical variables, you have to convert them into usable form. You can never use the categorical variables as it is. The reason is, some of them are numeric. When you combine a numeric and non-numeric data, the equation will never fit in a right form. So you have to convert them. For that, in Python, there is a function called getDummies. That is called dummy variable. You pass it car model, it will, if there are 5 models, it will generate the if you can do with single linear regression. Okay, understanding R square. We talked about R square. Okay. R square is always positive even when the relationship between the variables is negative. Because you can say what is the probability. 0 probability means throw away that equation. It is of no use. Okay. 50% probability, okay, not bad. 70 is a good. 80 much better. Right? So R square lies between 0 to 1. Higher the values indicate, the points fall closer to the regression line. You understand that? Lower the points means loosely around. They could be either side of the regression line. Higher the values indicate that the line fits the data well. Lower indicates that the line does not fit the text encoded data in any form. Notepad, text pad, anything. If it is sum separated, which means name, comma, age, comma, weight, comma, college, 4 variables, you put that data into Excel, it will generate its own columns. Right? So the text encoding will convert the data into columns. So that is the CSV data. Okay? Fair enough? Okay. All okay there? Read Excel. So you take the Excel data, just do dot read CSV and it will read the data, it will generate the data into columns. Okay. So clear, because I can't get into each of them, will not be able to do the business case. Very simple, import, you are importing a library, you are importing something called pandas as PD. As PD means, henceforth when you use your PD, it is referring to pandas. And then you are importing another called variable called numpy. Okay, these are the statistical modeling variables. Then you are reading your spreadsheet. What does the spreadsheet has? Serial number, percentage income, and salary outcome. Okay. So here you have formed something called a data frame. DF is a data frame. Okay. And this is the variable you created here. MBA underscore salary underscore DF. That is data frame. So the modeling technique is everything you read, you put it in a data frame, virtual table. And either you may keep the full table or you may remove some columns later down the line. So this is your original data set. That is called data frame. How many columns it has? 3 columns. Okay. Now we created that variable, and when you say .info, this library will return what is the information contained in that table. How many columns are there? 1, 2, 3. What it says, all the 3 are not null, which means they have some data in it. And all of them are, this is integer format 64, float format 64, and integer 64. Okay. Now it is trying to create the feature. Feature here is typically referred to as the dependent variable. Okay. In this case, your 10th class marks is a feature. Okay. So it is trying to kind of create a feature. Now this is your modeling equation typically, right? You have imported a statistical model as SM. This is the model in your Python. You are saying that add a constant, use this data frame, and then what is the variable? Percentage in 10. So it is trying to generate, take this data, 10th class marks, and see how much there is an influence of that in the salary. That is the equation we are trying to build. So it has come up with the following output. Okay. Now, what we are trying to do, what is this? Train test. So, within the existing data, we are forming 2 sets of data. One is your X, that is your 10th class marks. One is your Y, that is the MBA salary. So here, we are trying to find 70, what is this 0.8? 80% of the data we want to use for training the model. And 20% of the data we want to use for testing the model or validating the model. So basically, train Y, not only excess but Y also we are protecting it. Okay? We are not consuming entire Y. We are only consuming 80% of outcome, 80% of dependent variable. That's the equation. Okay? Now, this statistical model has a function called OLS. Okay? That is forming the equation. Sn.OLS, train Y and train X dot fit. Okay? We are using training data only, not the validation set. Okay? Now that dot fit is actually mathematically fitting the equation. So we are not doing any manual math. That model is fitting the equation and it has come back with this outcome. Constant and percentage in grade is this 3560. Okay? What it is saying is, if you go back to the regression equation, y is equal to a constant plus something multiplied by x. That is the equation. Y here is your salary. What is the constant? 30,587, just rounding. What is the variable? 3560. So what I am saying is salary equal to 30,587 plus 3560 multiplied by x. That variable here is x. So this is your regression equation. Okay. So what we are saying is there is a dependency. So for every percentage increasing in 10th class marks, the multiplier is 3560. That's what. As per the model. There is a, what is the relationship? Are related by a factor of 3,500. Okay. This is the initial impression we got. Now, do we stop here and apply it to everybody? What are the next steps we should be doing from here? Testing the model. We have not used the 20% rate. Diagnostics. You have to run R square. You have to run the outlier check. Right? So that is where we will get into now. Model diagnostics. Coefficient of determination R square, hypothesis test, analysis, and residual analysis. Okay. Model diagnostics. We are checking the residual analysis. So there is a library called pyplot. This is for plotting your data. Okay. So you import this library, right? And you are trying to plot. Very simple. No, you don't need the whole square, graph sheet. No, nothing. No numbers. Just put it. It will generate the chart for you. Okay. So what we are trying to do is probability and MBA salary. What is the probability that I predicted the MBA salary correctly? Probability plot. This is the plot. Okay. Now, by looking at this plot, we have seen some graphs. What do you think this plot is indicating? It is linear. But is it favorable, unfavorable? Is this a good model or a bad model? Why good model? It is. It has all the residuals along the line. If there are some here, what does it mean? You cannot predict the model. You cannot predict using this model because some are outliers, right? So the first validation, what it is suggesting is your equation that you have formed looks like is pretty reasonable with the residual analysis. Now we'll go and do more diagnostic. Okay. So this is the residual plot for the MBA salary prediction. The residual plot means it will take your outcome and check with the predicted outcome and see what is the error. Okay. So we assumed with our curve, it's a normal distribution. 3 standard deviation this side, 3 standard deviation that side. That is how all statistical assumptions are. Now, for us to make that assumption true, the residue, which is the error. So this is plotting the error. All these are errors. The errors should also be equally distributed, linearly distributed, equally distributed. If they are not, then it will fail the diagnostic. This model you cannot use. You have to redo the model and try to find some other variable. Okay? So this plot indicates that the residuals are equally distributed. So this is a favorable diagnostic. Now we are getting into outlier analysis. There is something called z-score. Okay, let me actually get back the slides here. Predicted minus actual are normally distributed. The variance of residual is constant. The function form of regression is correctly specified. Okay. Now, if it is not constant, this is how your chart will look like. This is a good example of a bad model, which means your residuals are all over the place. So you cannot use that model. So your graphics library in Python is very easy. You take the model, apply the residuals, you see what chart you get. If you are getting this, then stop the model then, it doesn't help. Okay. Now this we talked about, the favorable model. This is the outlier analysis. So what it says is, this is all your regular data. We talked about age of the average class, 17 to 21. But if it is 25, you can't do it. That's an outlier. Now how do you identify outliers in these 50 people? Because you trusted that 50, you consumed 80% of it and you developed the model. Now we take each variable, we have to inspect whether it is an outlier or not an outlier. So these are some standard ways. Okay. Anyway, you will get the material, don't worry, but just look at the approach. There is z-score, you have a library to calculate the z-score, and there is a threshold. Z-score of more than 3 may be flagged as an outlier. Okay. If a data point has a z-score of more than 3, then likely you have to remove it. If you want to use the model, okay, but remove that data from the 50, redo your model. Okay? Okay? Then there is an equation called Mahabalan's distance. We'll come back to it in multilinear. And there is something called Cook's distance. Okay, we will inspect that. And the last one is leverage value. So you apply these 4 diagnostics and then see whether you want to use that model or you should reject the model. Okay, for each of the variables, right? You plot this Cook's distance for all the observations, and we have done the z-score. Z-score, what did we say? If the z-score is above 3, you have to remove those variables. They could be your outliers. Okay. Then we move on to leverage plots. Okay, these are something called leverage plots. Again, your library will do it. Okay, there are some thresholds. There is a chart on how to read these leverage values and how to accept or reject the leverage value. Okay. Okay. Now making the prediction. Now we are done with the model. Because our case, there are no outliers in the MBA data, and more or less what we are seeing is the residuals are fitting, they are normal. Okay. The plots are fair enough, and then now we are computing the R square. What did we say the range of R square is?
0 to 1.
0 to 1. Higher is good or lower is good?
Higher is good.
Fair enough. Now in this case, it cleared all the diagnostics. Okay, which means it's a good model. Now R square will indicate how much it will predict the result. Okay. So now when you calculate R square, it is saying 0.15 is your R square. Okay. Now let me go back here. Okay. So 0.156, which means it is a probability. It says grade 10 marks explain 15.6% of variation in the salary. What does that mean? Can somebody explain? 10th class marks are explaining 15.6% variation of the salary. Increase in salary. Okay. Now, what happens to the other 85%? 15% is it is explained. What happens to the other 85%?
Graduation, rest of us data,
Louder.
rest of us data or intermediate
Huh.
and that we can
That's a good thought, but within the framework of this, we are only inspecting 10th class marks. So we don't have other data. So, go ahead. Huh? Test?
It will does not show variation in their salaries.
It will.
Does not show variation in their salaries.
There is not so much variation.
No, sir. 85.
85, okay, you are almost there. So what it is indicating is, with this model, if you only give me 10th class data, I can predict 15.6% of my other 85% I cannot predict. Simple. Okay? This model is good for predicting 15% of your outcome. Other 85% I cannot. If the R square was 0.85, what does it mean? 85.6% I can predict. 15% I can't. Okay. So that is what is the R square. Okay. So this kind of concludes this case study. Now, before going into the next session, anybody is sleeping yet? Huh? No? Can you all stand up?
Yes,
Please.
One, two, three, 5.
There's no chance. You went home, I think. Come on. 1,
2, 3, 5, 6, 7. 1.
out. You are coming there. 1, 2.
2, 3, 5, 6, 7, 9, 10.
12, 13, 14.
You want to go out, I think. 1, 2, 3.
5, 6, 9, 10.
You said 8, yeah? Okay, done. When you were clapping with your...
13.
15.
What is this, yeah? Data science and statistics and all. You don't know how to count 50. Shame on you. Come on. 1. You are in or out?
Out.
Declared. Declared out. Okay, 1.
1, 2, 3, 5, 6, 7, 9, 10.
11, 12, 13.
15, 16, 17.
Good.
21, 22, 23, 24, 26, 27.
In the real world, the variables are hundreds and sometimes thousands. Right? So first is you have to identify which variables you want to inspect and then make a outcome, predict the outcome based on the input. Right? So the key part here is the decision makers to focus on them to manage what you want to inspect, and some you have to reject straight up because data is incomplete. If you have 100, let me give you an example. If you have 100 variables to predict a customer cardiac patient cost, you have 100 variables, let's say. Okay, this group has 100 variables. This group has 10 variables. Okay. If you are a hospital, what is good for you? This one or this one?
10 variables.
Why? No? Louder. Easy. Somebody said it is easier to manage 10 variables. It is difficult to manage 100 variables. Assume that you are sitting in the counter, one patient came, and you gave a form, please fill 100 variables. How that person will feel? And how much intent he will have to give 100 variables? Very less intent. 10 variables? Mostly possible. Even that there will be errors. But likely there is a higher chance of using those variables. So our intent is to identify the key, these are called KPIs, key process indicators, which are the ones that are influencing. Then identify the strategy and then run your validation. Okay? So the good practice of multilinear building is basically look at your visualization, scatter plots that we have looked at earlier. Look at some of those. Let's say a vehicle insurance company found that among new car drivers, young male drivers have a higher average claim. Is this a reality? Could be. Some of you drive two-wheeler.
Yes.
Okay, let's categorize two types of two-wheelers: scooter and
Bike.
bike. Okay, and let's say this segment is scooters and this segment is bikes. The potential for accidents on bikes are higher. Okay, we are assuming here some social conditioning that is drained into our head. What is that condition? Typically, girls drive scooters and boys drive bikes. And likely boys are rash drivers. So they will have a higher premium. Now with this, let's say you are an insurance, you have to issue policies. Okay? Now, if you ask them, okay, are you a male or a female? And if you are a male, by the way, I am going to charge higher. Would the person come and buy insurance from you?
No, sir.
Why not? Insurance is higher, but that is the reality. That is the true fact. But the moment you say, if you are a boy, I will charge higher, there is a bias in it. Okay? So you are upfront telling, flagging it. Now that is something called PII, personally identifiable data. In some countries, that is a legal crime. You cannot take somebody by their gender, race, any demographics or age or anything else and penalize them with their policy or health benefit. They can't. Now, how do insurance companies do business then? If you ask, there is a problem, there is a legal crime, you cannot ask, you are a male or a female. Okay, you have to issue the policy. What else can you look at in this case? Think about it for a minute. Very, very simple, straightforward. Scooters, bikes. You can't ask, are you a male or a female? You have to give them a policy. Right? And you want people with more accidents or less accidents? Very good. That's a counter thought, but in this case we want less accidents. Because insurance company will run out of business if there are more accidents. Okay? So how will you predict or what?
She is right actually. By 2030, India is going to surpass China in population. So we have to reduce the population. There is a logic.
So now, with that background, what else will you use to issue a policy? How many variables you have in this scheme? What are they? Male or female, which you cannot capture. Now, when we started the conversation, we said insurance is higher for bikes and lesser for scooters for several reasons, cost and potential accidents. Now, you cannot take the male or a female into the equation. But what does our social conditioning say? Females are driving scooters likely and males are driving bikes. Okay, if you collect the model of that vehicle, is that a legal offense? It's not a legal offense because you are an insurance company, you can collect the model. Is it a Bullet 350? Is it a Bullet 500? Is it a Activa? What cc? Is it a Aviator? Is it something else? TVS 90? You can collect the model. Now, by reading the model, would you understand is it a bike or a scooter?
Yes, sir.
Absolutely yes. Why? Because all the models are published. If you put that model, it will tell you whether it's a scooter or a scooty or a bike. Right? So now, if you are an insurance company, what will you collect? Collecting the male-female data is an issue, legality issue. Collecting the model is not a legality issue. So, you can collect the model, still run your business and figure out whom to issue the policy and whom to charge a premium. Right? So, does this give you some clues? 100 variables are good or not good?
No.
Why? Complicated. 100 variables to watch is not fun. Okay? What do we want to chase?
Number of
Okay?
boundaries.
These are the parameters. Okay? Anybody bowling?
Yes, sir.
Okay, who is the bowler? Okay, go ahead.
Wickets,
Wickets, economy rate,
strike rate,
strike rate,
spin rate, wide, sir.
huh,
Phaser or spin
huh. Does that matter? Okay.
According to the
So, okay, we'll spend a minute. This is a key point. You don't know the player name. Okay? You have a strike rate of a player 1 whose strike rate is 15. Which means every 15 balls he bowls, he is taking a wicket. Okay. Another guy whose strike rate is 10. Another guy whose strike rate is 50. You don't know which one, who is a spinner, who is a fast bowler. How do you choose? Strike rate. So end of the day, when you have data, you cannot get that bias influence the data. So if the average is 50, doesn't matter if it is a Pant or a Dhoni or even Bumrah, doesn't matter if he is a batter, pick him up. Or if it doesn't matter whether he bowls googly or fast, because you are spending money. Now separate your passion of playing cricket. I appreciate you guys playing cricket. But as a franchise, you care a damn. Because IPL is about winning games. Does it matter big names? It doesn't matter. And many times it is proven over. Rajasthan Royals won the first IPL.
Yes,
They had most unusual players that nobody knew. And the team of uncles, who is the team? Chennai won too many cups. And they had the least played players. So, what we have to try to protect ourselves is biasing with the names, biasing with the nature, try to stick to the data and quality of data, simple, and try to minimize your variables, one. Second, we want lesser variables because it is easy for us to deal with, correct? That is called multi-collinearity, which means if a variable depends on a variable and depends on a variable, use only one. Example, bowler, strike rate, economy rate, and something else. There are 3 or 4. Figure out what is the most critical and use them. Let's say you have 10 bowler parameters, but inspecting 10 is a little hard. You want to inspect only 3. Try to use the unrelated one. Maybe number of wickets. Is number of wickets related to strike rate? Somebody played 10 years, you really don't know. He would have played very badly for first 5 years. Strike rate of 100. Next 5 years, strike rate became 50. Last 1 year, strike rate is 10. So volume of wickets he is picking up is more and more in the last 1 year. That doesn't show in the number. Does that show? No, it shows only he picked up this and it averages his entire strike rate. Isn't it? All the 5 years, wickets, economy rate,
Strike rate,
strike rate,
spin rate, wide, sir.
huh,
Phaser or spin
huh. Does that matter?
Okay. According to the
So, okay, we'll spend a minute. This is a key point. You don't know the player name. Okay? You have a strike rate of a player 1 whose strike rate is 15. Which means every 15 balls he bowls, he is taking a wicket. Okay? Another guy whose strike rate is 10. Another guy whose strike rate is 50. You don't know which one, who is a spinner, who is a fast bowler. How do you choose? Strike rate. So end of the day, when you have data, you cannot get that bias influence the data. So if the average is 50, doesn't matter if it is a Pant or a Dhoni or even Bumrah, doesn't matter if he is a batter, pick him up. Or if it doesn't matter whether he bowls googly or fast, because you are spending money. Now separate your passion of playing cricket. I appreciate you guys playing cricket. But as a franchise, you care a damn. Because IPL is about winning games. Does it matter big names? It doesn't matter. And many times it is proven over. Rajasthan Royals won the first IPL.
Yes,
They had most unusual players that nobody knew. And the team of uncles, who is the team? Chennai won too many cups, and they had the least players.
Yeah.
So what we have to try to protect ourselves is biasing with the names, biasing with the nature, try to stick to the data and quality of data, simple, and try to minimize your variables, one. Second, we want lesser variables because it is easy for us to deal with, correct? That is called multi-collinearity, which means if a variable depends on a variable and depends on a variable, use only one. Example, bowler, strike rate, economy rate, and something else. There are 3 or 4. Figure out what is the most critical and use them. Let's say you have 10 bowler parameters, but inspecting 10 is a little hard. You want to inspect only 3. Try to use the unrelated one. Maybe number of wickets. Is number of wickets related to strike rate? Somebody played 10 years, you really don't know. He would have played very badly for first 5 years. Strike rate of 100. Next 5 years, strike rate became 50. Last 1 year, strike rate is 10. So volume of wickets he is picking up is more and more in the last 1 year. That doesn't show in the number. Does that show? No, it shows only he picked up this and it averages his entire strike rate. Isn't it? All the 5 years, principal component analysis, PCA. What principal component analysis is it extracts the best outcome from the 1000 variables. You throw 1000 variables at PCA. PCA is a statistical library available in Python. It will come back and say, this 10 variables will pretty much extract what 1000 variables would have extracted. So don't worry about the 90. Right? So this is another technique that is widely used in the statistical modeling, where data scientists want to use piece. If you have 1000 variables, don't worry, don't do all this multi-collinearity behavior. Just put PCA first step, reduce the 1000 from 10, and then start building the model. Because you are reducing the complexity upfront, right? So that is the reducing the model comp we talked about. Yeah. So IPL data. Okay. So let me hop on to this case study maybe in 10 minutes because we have 2 more topics to do, right? So you have the names here. This is a slightly older data to reduce the politics part of it out of this case study. So you have several things, age, country. I mean, age for now is categorized because they didn't want to share the age because sometimes it becomes complex. So they coded like 1 is like under 20, 2 is like under 25, 3 is under 30, something like that. So for now, don't assume that age 1, 2, 3 is literally the age. It is a category of age. Okay? Country, team, you know, and then what is his role, all-rounder, bowler, etc., runs, wickets. Total there are about, what is the sold price? What are you predicting? What is the selling price? And now your challenge is, how do you use these A to Z, how many variables are there? 24. Okay. Now, these, I thought there are 26.
26.
Yeah, 26. So basically, your intent is to calculate the sold price based on these 25 variables. Now we will get into the Python model. Okay? But what does it do for me as a user? Louder. Louder. Bitcoins is one part of it. Yes, but how does it help you as a user?
Black money you can
Black money we can convert into Bitcoin. Not a fair statement, but Bitcoin is a currency part of Web 3.0. Okay. Now let's go and figure out where Web 1.0 started, where Web 2.0 happened, and why Web 3.0. Okay. What is Web 1.0? Basic browser. Okay. I think your generation has not seen 1.0.
only HTML code.
Only HTML, and these were days when the websites were old style, where you scroll and scroll and scroll. It's like a big blog. You go, keep watching, keep watching, keep watching. Now Web 2.0 came, which started creating ecosystems. Facebook is an ecosystem. So what happened? You started creating groups of networks. You are part of a network, and what you do alerts the rest of the people on the network, and there is an exchange happening between you and other people on that platform through a network philosophy. Okay. Now Web 2.0, is there engagement with different people? There is engagement with different people. Okay. There is interaction. You can chat, you can post, put a video or an audio based on the platform you are, so on and so forth. Who is making money in Web 2.0? Louder. Who is making money? You are using Facebook. Are you making money or Facebook is making money?
Facebook.
Facebook is making money. You are using Twitter. Who is making money?
Twitter
is making money. You are using Instagram. Who is making money? Instagram is making money. So the platform is actually making the money. Okay? Only so-called designated people make money on that platform. Example, influencers. Okay? A Beckham tweets, what happens? 1 million people watch. And based on the count of people, Beckham gets paid. A Virat Kohli puts a blog. Okay? People watch on Insta, he gets paid. So there are thresholds. Okay? But generally 90% of the people don't get benefited in Web 2.0. People like you and me. I am on LinkedIn, I share posts, people can comment on that post, I consume data, I share data. It's a two-way platform. Who is getting benefited? I don't get benefited, right? Yes, there are indirect benefits. Somebody can watch me, what I am doing, maybe when I share my profile later, you could go look up what did I do last 20 years, so on and so forth. But the real value is created for the platform, not for you. No, Web 3.0 is a philosophy where to change the value equation to bring the user into play. So far, Web 1.0 was one-way street. You could only go one way. Somebody decides to share their information, they put a browser, you can only scroll, you can't do anything. Web 2.0 exchange started. Web 3.0 is creating value for participants of that platform. Okay? So we talked about hybrid work, we talked about time zones, we talked about sprints, and now we talked about Web 3.0. Okay? So crypto, Bitcoin and DeFi are some examples of platform creating value for the users. Okay? So crypto, while there is a lot of good, bad, and there is government policy around it, crypto is becoming a very widely used currency. What is a currency? Example.
Rupee.
Huh?
Dollar.
Dollar is a currency. Why is dollar powerful?
All the ones
GDP.
Simple. For $1 you have, I have to pay 80 rupees now. When I was in college, I used to pay 20 rupees for $1. Now I am paying 80 rupees. So it is a very powerful currency, and the exchange value for rupee is more or dollar is more? Dollar is more, right? Now, for us to interact, we need a currency. Okay, that currency you go to Dubai, buy Dubai currency. You go to Rome, buy Rome currency. The challenge is with these currencies, there are so many third parties involved. Let's say tomorrow you get a college admission to US and you travel. You have to carry dollars. You have to go somewhere, give your money, convert that to dollars. There is some commission involved. There are companies that take commission. Then when you take those dollars, and let's say instead of US, you changed your mind, now you got a better admission in UK. What do you do with the dollars? Change it to pounds. You pay that again. So end of the day, the current value currency systems make a lot of third parties make money. And the left side and the right side are losing. Right? The third parties in the commission are making money. So this currency, the crypto or Bitcoin or DeFi, we'll talk about it, is where they eliminate the third party. Okay? And there is a currency that whole world follows. Okay? Now, there was a king who created a currency with skin of animals. He said, forget no gold coins, no silver. All of us know there used to be gold coins. You don't know? I don't know. You know that? Okay, there used to be gold coins, then there used to be silver and whatnot. One king was smart, saying that I will create a currency of my own. I'll take the leather and put my seal. Guess what happened later? What is the problem with that currency? Lack of? One is you have to kill a lot of animals to make the second is anybody can duplicate that currency. I can kill 10 animals, go to the forest. Earlier they allowed people to kill. Now there's a lot of legal issues. You go kill 2 animals, make a currency. So it is inconsistent. And in winter animals won't be visible. There is no currency. In summer too many animals. So there is imbalance. So you want a currency that everybody can treat it equally. What is the currency other than your dollar or rupee that people generally agree with? Any guess? Not these ones listed, but anything else that you guys know of? Gold is a very good currency. 24 karat gold has a value whichever country you go to. They'll put a mercury on it, they will test it, they'll give you the value. Likewise, but gold is a physical asset. How much gold you can carry in your pocket is limited, right? So the new Web 3.0 world is where you create a currency that most of the globe agrees with. Number one. Number two, why is it now before going into the is it good, is it bad, Nirmala Sitharaman said, I don't agree with this currency, but if you make money, I will charge you 30%. I don't like it, but if you play that game, no worries, you play that game, it is legal, but I tax you 30%. That is India's stance on that currency. So I don't want to take the debate too far. Very, very simple. Why the currency is valuable is, most of the Fortune 500 companies have 30-40% of wealth in Bitcoin. What does it mean? They are already generating Bitcoins as their wealth. So what will they transact with tomorrow? Bitcoins. Right? So that is where Web 3.0 is even, it's an even playing field. Right? Bitcoins are universally acceptable. By the way, don't take this as Bitcoins are good or bad. It is a currency. Is it legal? It is legal. In our country, the government stance is, fine, you use it, but I will tax you 30% for every benefit you make on Bitcoin. But currently, Bitcoins are tradable across the globe. Most of the Tesla, have you heard about Tesla?
Yes.
So Tesla has 40% of its wealth in Bitcoins. So that is how companies are going towards, because it is quickly interchangeable wealth. You can exchange Bitcoins for something else if somebody else wants those Bitcoins. Simple trading, no commissions involved. On that day, whatever is the value, you get it. So Web 3.0 is a multi-value platform from that network. You reap benefit also. It's not a one-way or a two-way. You as a user also will get benefited, and there is no bias. The Bitcoin, let's say there are 2 Bitcoins, there is Bitcoin and there is one more, there are top 2 currency exchanges. They are currently trading at 15 to 22 lakhs for one coin. If you want to buy one coin, Bitcoin, it's about 20 lakhs or 15 to 20 lakhs. That is the currency exchange right now. Okay. And Bitcoins have been building for decades, at least 20 years. In India, we came to know about it late. Okay. So Web 3.0 basically is about value creation, multi-platforms, and user reaping the platform benefits, not just platforms making money. Okay. Last part is DeFi is a decentralized finance. Okay. Very complex topic. Since you guys are first year, I don't want to get into it, but very simple thing. We told you have rupees, you pay exchange to get dollars. If you want pounds, you have to pay exchange again. If you want dirhams, you have to pay exchange again. But DeFi says, if you have one currency, you can trade across the globe and you don't have to pay any commission to anybody. Simple, momentarily. Today, if I have dollars in my Cisco stock in San Jose, I sell, it takes 3 days. And every transaction, I pay $25. All that is gone with DeFi. Anybody can trade anywhere, the currency is converted instantly, within seconds value realization happens. Right? That's the decent. That's where Web 3.0 is. Now the idea of sharing this Web 3.0 with you guys is you have to figure out where you belong in this new world of agile, bitcoins, cryptocurrency, hybrid cloud, agile, sprints, etc. So keep your channel open when you learn. For next 3 years, 2 years you are in college. Okay? You have a brilliant opportunity to build a hobby to learn one of these Web 3.0 technologies. Don't go all over the place. Each of them is an ocean. You will get swamped in it. Okay? Pick up one. Just one. DeFi, crypto, anything. And don't play with your money. Play with the technology. Understand what is the platform, right? And where you can play a game and what techniques you want to belong in the Web 3.0. Okay? Another 3 years you can build those and you will be ready when it hits India. You have that advantage with you now. People like us, we have to run, on the run we have to learn because it is right here. Right? So you have that opportunity. So it was critical for you to know the lay of the land for Web 3.0. Okay, so this one ideally we wanted to do like a business case and a little bit of a role play, but with the time, I look at the clock, it's not going to be possible. So you can do a reading later, I'll share the content. So these are some roles in a typical software company. We talked about several roles. There are new roles that is coming up, which is one common one is a Chief Customer Officer. All of you would have heard about CIO, CEO, COO, right? So this is a CSO, Chief Customer Officer. And the new one, the other one that is coming up is a Chief Product Officer. Okay? So there are new businesses being developed, new roles being carved because the new age software services needs these roles. Okay. Anybody uses Uber, Ola?
Yes.
Okay. Do you own that car or you lease it or you pay for it? You pay for it. Okay. Very, very simple. That is called a subscription model. You pay the phone bill every month?
Yes,
subscription. You pay for your rental rent? Subscription. So the new age philosophy is where people want to pay subscription. You want furniture? Rent your furniture. I don't want to buy furniture. You want a car? For a weekend, just rent it for a weekend. Right? So this subscription economy is where the entire digital platforms are going towards. Earlier, it was only software licensing, which means if you own Windows 10, you pay some 6,000 or 7,000 rupees to Microsoft. Lifetime, you get validity. Right? So that was the model. But more and more people and companies now want a subscription. And the entire financial model of these companies works on a periodic basis called fiscal quarters. 3 months is a quarter, 90 days. Okay? And every quarter they want to commit and recommit their numbers. Okay, based on where I stand now, how much do I want to spend? How much do I want to save? How many people I want to hire? How many people I want to fire? And with that, subscription economy looks very easy for them. They don't want to buy too many assets or they don't want to hire too many people. They want assets only to live up till 90 days. Simple. That's the business model. And CEO is the one who is chartered with that function, making the company run. Okay? So the subscription model started about 10, 15, 20 years ago with a lot of platforms. In India, Uber, Ola are popular. Airbnb is another such, if you guys have used, very popular subscription platform. Now it has penetrated in India as well. So more and more your mindset will be tuned to a subscription mindset. How much you pay for Netflix, there is no subscription. If you want to use another channel, you pay for the month or 3 months, then go forward. You don't pay for, the long-term commitment is basically people try to avoid. So subscription economy is driving the value very quick cloud, agile, sprints, etc. So keep your channel open when you learn. For next 3 years, 2 years you are in college. Okay? You have a brilliant opportunity to build a hobby to learn one of these Web 3.0 technologies. Don't go all over the place. Each of them is an ocean. You will get swamped in it. Okay? Pick up one. Just one. DeFi, crypto, anything. And don't play with your money. Play with the technology. Understand what is the platform, right? And where you can play a game and what techniques you want to belong in the Web 3.0. Okay? Another 3 years you can build those and you will be ready when it hits India. You have that advantage with you now. People like us, we have to run, on the run we have to learn because it is right here, right? So you have that opportunity. So it was critical for you to know the lay of the land for Web 3.0. Okay, so this one ideally we wanted to do like a business case and little bit of a role play, but with the time, look at the clock, it's not going to be possible. So you can do a reading later, I'll share the content. So these are some roles in a typical software company. We talked about several roles. There are new roles that is coming up, which is one common one is a Chief Customer Officer. All of you would have heard about CIO, CEO, COO, right? So this is a CSO, Chief Customer Officer. And the new one, the other one that is coming up is a Chief Product Officer. Okay? So there are new businesses being developed, new roles being carved because the new age software services needs these roles. Okay. Anybody uses Uber, Ola?
Yes. Yeah.
Okay. Do you own that car or you lease it or you pay for it?
Lease.
You pay for it. Okay, very, very simple. That is called a subscription model. You pay the phone bill every month?
Yes, sir.
Subscription. You pay for your rental rent? Subscription. So the new age philosophy is where people want to pay subscription. You want furniture? Rent your furniture. I don't want to buy furniture. You want a car? For a weekend, just rent it for a weekend, right? So this subscription economy is where the entire digital platforms are going towards. Earlier, it was only software licensing, which means if you own Windows 10, you pay some 6,000 or 7,000 rupees to Microsoft. Lifetime, you get validity, right? So that was the model. But more and more people and companies now want a subscription. And the entire financial model of these companies works on a periodic basis called fiscal quarters. 3 months is a quarter, 90 days. Okay? And every quarter they want to commit and recommit their numbers. Okay, based on where I stand now, how much do I want to spend, how much do I want to save, how many people I want to hire, how many people I want to fire. And with that, subscription economy looks very easy for them. They don't want to buy too many assets or they don't want to hire too many people. They want assets only to live up till 90 days. Simple. That's the business model. And CEO is the one who is chartered with that function, making the company run. Okay? So the subscription model started about 10, 15, 20 years ago with a lot of platforms. In India, Uber, Ola are popular. Airbnb is another such, if you guys have used, very popular subscription platform. Now it has penetrated in India as well. So more and more your mindset will be tuned to a subscription mindset. How much you pay for Netflix based on subscription. If you want to use another channel, you pay for the month or 3 months and then go forward. You don't pay for the long-term commitment is basically people try to avoid. So subscription economy is driving the value very quickly in a short period of time. Okay? So we'll move on from there. We talked about how do you decide what to build. Okay? In a 15-day interval, we talked about Spotify features. Somebody said liked songs there. So those features, how frequently you build and how do you decide? That philosophy is called most viable product in a agile philosophy. And basically what they are trying to do is build a minimum viable product in the shortest span of 15 days, right? And see whether customers use it. If customers use it, build more, right? That is the philosophy. Okay. We will move on. This is how a typical agile team functions. Again, ideally, if time permits, we would have tried to do kind of a role play with this. See, basically, in 15 days, every 15 days you are releasing a feature. You don't have too much time. So what people do every morning, 30 minutes, there is a sprint call. Talk about backlog, what to do, what is in progress, what is in testing, is it completed? Very, very simple. Maybe later in your second year or third year, when you take some project, try to apply sprint philosophies to it. Very simple. Every morning, let's say you are trying to organize your library and 5 or 10 of you are working on it, right? Very simple. How much is left on the left side? That is the total work backlog. Okay. What is the work that is still to be completed? Then who is doing what to do? If there are 5 people, clearly carve out what work, who is doing. Next, who is in progress? So some people have the skill and they have moved on. They organized 100 books. Maybe some people don't have the skill, they are stuck. So now those are called blockers. So people who come into those 30-minute meeting are expected to put their hand up and say, hey, I don't know how this works, I need help, right? So those are the ones that are in progress, but within 90 days, every 15 days, you are pushing a new feature out there. Works, build more of it. Doesn't work, discard feature. Simple, right? That is how the new agile frameworks are working. What I suggest is in your next 2 or 3 years again, try to use those principles in your day-to-day work. Don't have to read it or don't have to kind of mug up anything. Just take a small project for your own college class, whatever works for you. Put that in an agile philosophy. There is a lot of information available, but all you need is this chart. Very, very simple chart. Who is doing what, who is blocked, what is completed, what is in progress. In millisecond, there is an event happening from the user on Spotify. What is the data generated? 350 terabytes. That is the amount of data generated. Because of every click you do on Spotify, there is an event generated and they track that event. So they created their own architecture. Right? They said whatever available in the market won't work for us. They created a philosophy called event-driven architecture, where they said that I don't want to communicate to 10 people. Okay? Let's say very simple event-driven architecture example. If a lion comes into this room, what happens? White noise. Huh? Everybody will say, I tell everybody to run. No, what will happen? Everybody is running. Why? There is a trigger, and the trigger is lion. Very simple. Because all of us came from survival. First we want to live, then figure out what the hell happens later, right? The same philosophy they have used here. So the older mechanisms was, let's say you have a phone, smartphone. One feature in this is not working. What do? You have to go somewhere, show the phone, they'll say leave the phone for a day. Or they'll say, okay, screen is gone, I'll replace. In the new event architecture, the moment an event is identified that your function was supposed to generate an event, that event did not get generated because that function did not happen when you clicked it, right? So before even you go, the system knows that events are not generating for this user, right? And then from there on, it triggers several other events for somebody to watch you. Okay, what is the next move of this user? Would the user go to a store? Would the user go to a service, etc.? Instead, they will reach out to you. You get a ping. Hey, looks like your touch is not working. What can I do for you? This is the new age philosophy, which is based on true event generation mechanism. Okay. Now, last example, and we'll wrap it up. Okay, a short story. A person in the US, she's an intern. She was kind of doing some stuff. Then she gets next day she gets a bouquet from Burger King. Burger King CEO sends her a bouquet with flowers and 2 very tasty burgers and some onion rings and French fries. I'm sure all of you know about them. I don't need to explain. She gets it. Now she's like, why would a Burger King CEO send me these stuff? Her friends start to figure out, what were you doing? She said, no, I was interning. What were you doing? On interning. So she was doing something called social listening. Okay? What this is as a case study, she took Burger King stores, 5 stores. Every day she will go there. She will take pictures. She will post on LinkedIn, on Instagram, on Facebook, and several other platforms, ShareChat and several others. Her intent was very simple. Today I went to store A. These young set of people having a gala time are eating French fries. Today I go to a new store. There is a new menu. There is a, I don't know, Big Whopper burger that is launched, and then 10, college kids are all celebrating there. Today I go here, somebody is not happy with the onion rings because they're over. Simple. What she's doing is igniting conversations on social channels. Now what happens with those conversations? Somebody will watch it, somebody will like it, somebody will dislike it, so on and so forth, right? So she was trying to put out a lot of messages out there for people to consume. And the common part in that is, what are all the messages are talking about? Burger King. So she created a social theme called Burger King. And everybody is now listening into that. If I tell you that, can you spot a red colored items in the room? You take a minute and you spot. Now for next few minutes in your head only the red color items are going around, right? Same philosophy with social listening. She ignited a conversation on Burger King, and when they watched, those stores are selling more, right? Now this philosophy is called omni-channel listening. So you are making people listen to this message on several channels. So the Burger King CEO was spending millions of dollars on marketing. And this one girl outdid all of the marketers in these 5 stores because she made these 5 stores sell a lot more than the actual marketing campaigns which they spent millions of dollars in airports, in TV ads. So an intern's work got converted into a project, and the CEO said, would you like to join us? I want to offer you a job, right? So this philosophy generated out of nowhere. Who created that job? She only created her job. Okay, who created that philosophy, that theme? She only created that theme. Through listening channels, she made it interesting. You and me post, I don't know how many people will watch, but she made thousands and thousands of people watch it and tune into that channel called Burger King, right? So this is the multi-channel listening philosophy that happens, okay? The last example, and we'll wrap up this theme, is called conversational intelligence, okay? A marketer calls, okay, let me take somebody here. Okay, where do you live?
I am from Vijayawada.
Vijayawada, okay. Now, Vijayawada doesn't have a cricket team yet, I mean IPL. It does have.
No,
it doesn't.
no, sir.
Okay. So somebody wants to call you and send you a phone. One specific phone model, they want to sell it to you. Now they know your name, they know your age, they know you may watch cricket or some other game, they know you like few things. What do you like in the breakfast? What do you eat for breakfast? Pulihora. The friends give more data. Okay, pulihora. Huh?
What is it?
Water. Okay, good. What soft drink you like? Pepsi, Coke?
Thumbs up.
Thumbs up. Excellent. These 5 data points are enough. Please have a seat. Now a marketer calls you and doesn't talk about the phone. Talks about, how are you? What's your good name?
Prashant.
Hey Prashant, how are you doing? I'm doing good. Next, there is a conversational AI platform running, saying Prashant is from Vijayawada. He likes eating vada. He likes eating pulihora. And he watches this cricket team, let's say Gujarat Titans, he watches more often. And he reads news from Cricinfo. That is enough. Now they are talking about Prashant, that Gujarat Titans match yesterday, did you watch? No, you didn't watch. Oh, that was a good watch, good match, man. How did you miss it? So the conversation started. Now there's a, what did you eat yesterday? Pulihora. Excellent. So now this conversation building, what happens when somebody talks to you like that? What happens? You build trust instantly, right? So the trust is built momentarily with the help of artificial conversational intelligence based on what you browsed. Very simple. There is a conversational AI tool running that knows all your behavior from your Google, LinkedIn, Facebook feeds, that has enough data, that converted that into critical parameters, what we learned. It took 5 critical parameters. Now the telecaller or whoever pinging you identified your profile as this. Now he'll be only talking to you about 5 things. Towards then, how about the Vivo, I don't know, X97 model? Do you want to come over to our store and have a look? By the way, we have coffee free on the house. You will make a visit, forget you will buy or not. Right? So this philosophy is driven by conversational intelligence. So they make you believe that I know you with only very few 4 or 5 parameters that are generated by your data on social platforms with the help of conversational AI. Right? So now let's kind of put it all together. We talked about time zones. We talked about different teams working in different places. We talked about 15-day philosophy called sprint. It is part of a larger framework called agile. And then we talked about how companies are going into subscription model, which is a recurring based, 1 month, 3 months, whatever that is. And then how social listening, nobody related, Burger King story, a girl sitting somewhere, just doing an intern, gets a job because she is able to sell more burgers or more sales for the 4 stores out of nowhere. She has no relationship with the company, or she may not even like burgers, it is just stories she is putting out there, right? Then we talk about how conversational AI is leveraged in sales, right? So these are some platforms, they are all related somewhere or not on your data. So the basic foundation continues to be data. How you consume the data, convert that into artificial intelligence or conversational AI or omni-channel listening is up to the product you are trying to sell. You are thinking about tomorrow morning when you need to wake up. Now, is there alignment? No. What is the problem? It is very simple. Let's say there is no matchstick. I give you 2 rocks. We go back to stone era, and you have to cook something. Okay? You have to keep on rubbing the stones till the fire comes. Once fire comes, you will try to cook potato. Second time fire comes, you are trying to cook tomato. Third time rice, you are trying to cook rice. Fourth time, you are trying to boil the dal. Which one gets cooked sooner? None of them will get cooked. Because every time you are changing, your stream of fire, which is focus, is on 4 or 5 different things. Which of them will be completely thought through? None of them. So it is like you wake up in the morning, one day you decide, let me go to college. Other day you decide, no, let me go to movie. Third day you are saying, let me go to mall. What distance did I cover? Nothing. Right? So every day, all of us cheat ourselves with alignment. We think we are here, we are not here. We think we are learning, we are not learning. Somebody asks you, okay, what is the default answer? Did you say anybody, I feel like here? 99% answer is I am okay. Is that true? 99% of the time it is not true. But you are socially tuned to say okay. Now what is this doing to you? Creates misalignment. What you think, what you do, what is in your head, what is in your heart, and what is in your mouth are not aligned. So what will be the result? Potato cooked or dal cooked or rice? Nothing gets cooked. So basically try to have that alignment in whatever you do. At least commit 80%. We are humans, we are not gods. We can't commit 100%. Leave that. The rest part of it, other than we try to come, because every time you are not aligned, you are losing out. Okay? In every matter, even watching a movie, watch it peacefully. Watch it only first. No more phone messages, phone calls. What do I buy in the break? You have lost 60, 90, 120 seconds of the movie. Right? So, from henceforth, I am not expecting you to like every subject you have. Everything you do, you will have your likes and dislikes. Be clear. Don't cheat yourself. Okay? First year, what are the subjects you liked? Maths, commerce, C language, Python. Okay, be clear about it. Don't lie. Okay, be clear to yourself first. Okay, and focus on it. And if you have to tell somebody, tell that hey, I am going to focus on these three, or these four, or these four, whatever that is for you. If you are not able to do that, you are continuing to misalign, and that will only get. Will it get better or worse? Worse, because the train you have lost in Bhubaneswar takes 6 hours of drive to catch. So the more you miss in the next station, the third station, it is more difficult. The same thing, the more you are misaligned, it makes it harder. See, all our rituals, why do people say wake up at 6 o'clock, do the, is it interesting? Is it boring? It is boring, I accept. These rituals are triggering certain things in your brain, so you follow a pattern. And that pattern gets you into focus, and that focus gets you into alignment. And then you do productive things, right? So, if somebody, our rituals, most of them look boring. Go to a temple, wake up in the morning, take bath. Take bath is one huge task for me also, both my girls. They want to do it at 12, 1 o'clock on a Saturday, Sunday. Then there are challenges, right? But why do you think our culture created this taking bath in the morning? It is not that you have to put water on your head. No, the thing is, it is making you do certain pattern. Okay. When you wake up in the morning, do you search it? Where is my brush? You exactly know where it is. Why? You placed it there. Try to place it somewhere else tonight and find it tomorrow. But that is what you are doing in the class. Why? So many times, same thing, you are aligned. But the same thing that you do for survival, you are not doing for your growth. Why? Because it is boring. Right? So these philosophies of alignment and what focus can do are very, very powerful. But the way we see them are very boring. So simpler way, I won't say follow everything, be very good, life is boring. No. Do the things you like, but commit to them 100%. Let's say Monday to Friday, I'll take bath by 7. Saturday, Sunday, not. That is okay. That is fair enough. But don't be an illusion that every day morning, today I wanted to do, but I couldn't. Right? Now that is a misalignment. Because you know you are not going to do. Right? So, the alignment basically where your head, where your heart, 10% chance. Perspiration, we understand? Sweating, doing the hard work. Okay. Basketball, anybody? Good. You know the big Michael, the famous American player, Michael Jackson? Not the singer Jackson. There's another. Go and Google. There is a stalwart basketball player, Michael. The last name I am not clear. Huh? Jordan. Right. So he played basketball like nobody ever played. Okay, he was a stalwart. Then he got an opponent, he started losing to that opponent every time. Every time. For 8-9 years he made money. 10th year he got this opponent, he is losing. Then he created a ritual in the morning. Simple. In his home backyard, he will take the basket and put a goal. He will not leave his backyard till he puts 100 goals. How much time it would take? If I start at 5 AM, I want to put 100 baskets. He is a national level player. 30 minutes, 40 minutes, but maybe more. 1 hour. Okay. Now his condition was till he throws consecutively 100 baskets, he would not leave the court. Now what happens? Let's say he put 60 and 61th he dropped. So where would he start? Exactly like Mohan sir's case. You miss it, you start in the beginning. So he was almost losing his shoulders because of the practice. But he decided to not leave the court till he puts 100 baskets. Simple. From next season on, he never lost. Why? Not because he's lucky. Amazon has a brilliant robotics running behind their supply chain. Okay. They work on only one principle. Shelf to the user time. What is shelf? The store where the product that you have ordered is sitting. And user is the person who has ordered. They have only one simple philosophy. How to get that product to the user hands very quickly. How many products Amazon has? Any guess? Infinity. 500 million products. How many? 500 million products. Walmart is another giant which is now in India but used to be predominantly America's based. 20 years ago, Walmart's revenue was north of $100 billion a quarter. $100 billion is much more than a lot of companies' GDP and a lot of companies' entire wealth. That is what Walmart was generating. Amazon did not exist 20-25 years ago. Now, ulta. How many products Walmart has? Few thousands. How many products Amazon has? 500 million. Where are they? Can you see them? No. But when you order, is it coming to your home?
Yes.
What is the difference between Walmart and Amazon?
Walmart needs customer to physically get the product.
One good example. More.
Customer need to get the product without they wasting their time. So
That's
their
true.
revenue is
The
reduced.
revenue is true. And what else? So, see, one is the physicality of it. I have to go to the store and buy. Now Walmart also bought Flipkart and a lot of other companies. So they are playing the game of online stores also. But yes, there is a physicality which Amazon removed and done. Second thing is, when, okay, let's choose 3 stores that you buy your product from. Amazon, Flipkart and let's say Meesho. What is the precision of Amazon compared to Flipkart and Meesho? Is Amazon better or Flipkart or Meesho? Amazon is miles ahead. Okay? Because they nailed only one equation, shelf to user. Very, very simple. They are not focusing on anything. There is a product sitting, I don't know, in Chandigarh. You ordered a cricket bat. Somebody said bat in bowling. You ordered a cricket bat. How does that cricket bat reach this guy? Simple. They nailed that equation. Okay? And now, what do you need to compete with Amazon? Okay, now we know Amazon. Now we know Walmart. Now you are a consultant to Walmart. You are trying to help Walmart to slowly gain market which they lost. What do you want to do? Any suggestions? Think about it. We just talked about this. One simple thing they are doing is they have nailed an algorithm to send a product faster from the shelf to the users. And I'll give you clues. This company, have you ever heard of? Go and Google. Anybody knows about the company?
Just heard.
Huh?
Just heard the name.
Just heard the name. Okay, no worries. Go Google it. This company is created by 3 guys who completed their college 6 years ago. Very simple. They are from BITS Pilani. Okay. They wanted to create something on how to kind of automate things and try to build the supply chain in India, because India, the hardest thing is how the product reaches the user's hands. That is the hardest thing, because our country is huge. Products are maybe manufactured in Gujarat, Kashmir. Products you can buy sitting here. The product has to reach you. If you don't like, the product has to go back. Right? Now these big companies have billions of dollars of money to throw at it and fix it. But if you are a new company, you don't have that financial might. But what can you fight with them? On technology. Right? That is what these guys did. Now, they are not into retail sales, they are into automation in the manufacturing industry. Right? So, they nailed the automation in manufacturing through their AI-driven software called Kiva. Okay? Now, the homework for you is go figure out what is gray orange. What the hell are they doing? And why they are critical? Why they are claiming that they will beat Amazon? They are just 3 engineers from BITS Pilani who doesn't have billions of dollars of revenue of Amazon, but they are claiming we will beat Amazon in its own game. Purely on robotics, automation and supply chain integration. So today's world, the wealth is created by digital companies. We said Fortune 500, all of you took software companies. Nobody took any manufacturing or any other company. The second, what is the differential? One is the financial power. The second is the technology differential that you can take into the equation. So today's world, you doesn't need to be having a financial might of Amazon. You don't need that. All you need to know is what is the key factor that is influencing your business model. And if you can outdo that with your competitor, you are the new Amazon. Very simple. You don't have to be as big. You don't have to. All you have to do is pick up one parameter that you can beat them all. And technology is nobody's territory. You are as good with the technology that I am as good as anybody else. Some of us may take longer, some of us may take shorter. It is all out there. Nobody owns any of this. It is out there for you to pick up and implement. Right? So, the new age digital world is predominantly becoming not a product game, not a service game, but a technology game. Purely on AI, ML, robotics and automation. That is where the game is going. Do you know who had the India's largest supercomputer in 80s? Any guess? 80s, 90s? Huh? Tata? Tata? Somebody said, yeah, that's a good guess. Good answer. Usually government of India was very strong that time. So you can assume government of India. But somebody else has that. That somebody else is called Asian artificial intelligence, conversational intelligence. Go and figure out this Trigo. This is the world's largest grocery chain. Okay, it is in UK and completely automated. Less than 100 people work in this store, fully automated. Again, same automation and precision. Yeah, we talked about Indian Trigo. There may be a lot of local brands. Number one in India is ID Foods. ID Foods is the number one in India. And what happens to these foods if they are not sold in 2 days? They go waste. Let's say they have to send idli or dosa batter to Rajahmundry and Kakinada. How do they know how much to sell? 100 packets will be enough. 200 packets. Do they sell idli or they sell roti? Right? ID mechanism, ID Foods have a predictive algorithm that their store to user home is less than 48 hours. You pick up any ID product next time. It is not expensive. Coffee is 5 rupees, filter coffee packet. Idli dosa 50, 60 rupees. You can make 15 dosas or whatever. Look at on the label, 48 hours. So they are manufacturing, sending it to the right store, into the right user hands in 48 hours. Otherwise that packet is thrown out. And what is their precision? Any guess? ID Foods? 99%. Very simple. Okay. We talked about to your homes, to wherever you are, wherever people are. Right? So slowly the whole network is getting redundant and internet is becoming the new network. What is this grey orange doing? That could be ID foods, right? So every technology inference you see, try to understand what is going on behind it, right? And then you read a news, like Tesla is trying to now set up a store in India. They don't have Tesla cars in India yet, but they are now trying to set it up. Okay? So there is news in Economic Times about Tesla. So when you read that, don't read it from a political lens. This guy I know will do like that only, that guy. That is a very good conversation on coffee, but that doesn't add anything to us. Right? Figure out what the hell Tesla is trying to do in India. And who created Tesla? Excellent, right? So the same way, now here again, the person fantasizes so much that all of you know Elon Musk more than the product. Right? You have not driven in Tesla, I'm sure I have not driven it. I've seen Teslas, but it's too expensive. In Indian currency, the minimum Tesla is 60-70 lakhs. If this, the same model they sell it, it is 70-80 lakhs. So they are trying to alter that, ask the government to give a lot of subsidy. Modi is arguing with them. Ultimately, they will come to a price point and they will put a factory here and they will sell it. Okay? So try to follow that thing, but whenever you see Tesla or a car going, figure out what is running behind it, not the car, not the model. What is the business model running behind it? And keep your curiosity open. You don't have to sit in a class like this, or you don't have to go into Google and search the whole world. Use 2 or 3 listening channels. If you are tuned into conversational AI, look at these products, Sprinkler, SalesCam, right? Figure out what they are doing with text. What their game is, knowing somebody and text. Simple. Not very complex, right? Figure out a place in the future for you. That is where I want to wrap, okay? How would your future self look like? 4 years from now, what would you want to be? It will keep changing. It won't be fixed. That is all right. But if you don't put where you want to be, you will not be able to take any action right now. Same thing, one day north, one day south, one day east, one day west, net effect, 0. So, tune into one of the channels. Follow that channel and do something about it constructively. Simple. Constructively could be reading. And when you listen to news, listen it like an engineer. You are engineers, right? Your parents are paying a lot of money for you to come, and your teachers are spending hours for you to sit in the class, make it interesting. You are spending 4 years. 4 years is a lot of time. I will tell you, all of us repent once we are out of college. 100% guarantee. We will repent because this time we will spend just like that. But henceforth, try to figure out even your hobby, put a technology behind that. You have a hobby of watching blogs, watch one blog. Follow somebody. Right? So that is where I want to wrap up. I know the content of all these technologies is compressed into a very short time. I'll share the presentations through your instructors. You will get the presentation. I'll share my LinkedIn profile. I'll share my contacts and some case studies. Try to generate some interest and try to solve those case studies for yourself, not for me.
Yes.
Okay. Do it for yourself. So you know what some of these technologies are and where you want to belong in 4 years. Okay? Great. Unless you have any questions, I think, Monan, we can wrap up the session. Okay? Good?
Any
I
question?
know. Fair enough. No worries. Consolidate your questions and you can share it offline also.
A lot of things actually from and this is exactly what we were telling you. There are lots and lots of examples. They are called the analogy. An analogy is a parallel story. If this happens here, this can how you can teach your subject real life situations.
That's critical.
Yes, that is the most important thing. And then it becomes easy for you to understand. Okay? So, I think if there are any questions, fine, we will wind up.
Yes, sir, you can wind up. If anyone has any question, please.
Yeah.
Yeah, sir. Maybe we'll concentrate one topic at a
We
time.
can deep
This
dive
is a
on
general-
one
yeah.
kind of. Today we did like a 4 or 5 themes.
Yeah.